solving other equations, and I'm just going to be continuing with examples of solving my roots equations. This is the one that I solved last time. The cube root of 5x minus 2 is equal to negative 3. And we got the final answer of the solution set is negative 5 in the braces. Example 2. Square root of x plus 10 minus 4 is equal to 0. So step number 1 says we need to isolate one radical. That means we need to get this radical completely by itself. That means I need to get rid of this 4. And I do that by adding 4 to both sides. That gives me square root of x plus 10 is equal to x plus 4. And I forgot to remind you to pause the video and try it on your own. So if you want to do that from here, go for it. Step number 2 says power both sides. This is a square root, so we need to square both sides. Now you have to square both sides completely as it is. So on the right, you have to square the x plus 4 as one unit. You cannot square each term individually. On the left, the square and the square root cancels out, leaving me with x plus 10. On the right, since I have a quantity squared, since there is an addition or a subtraction involved, that means that we must FOIL x plus 4 times x plus 4. We do what the square tells it to do. We write the base times itself 2 times. So that gives us x plus 10 is equal to, first, x times x, which is x squared. Outside gives us a 4x. Inside gives us a 4x. So together, that gives us an 8x. And last, 4 times 4 gives me 16. At this point, I can see I have a degree 2 equation. So I can solve this by my factoring method or my quadratic formula method. I'm going to try my factoring method, which means I need to put it in standard form, so I need to set it equal to 0. I do that by subtracting x and 10 from both sides of my equation. That gives me 0 is equal to x squared plus 7x plus 6. It looks like it will factor, so let's go ahead and set that up. So I have x times x to give me my x squared. I have 6 times 1 to give me my 6. And then if I make this both plus, my outside gives me a 1x plus my inside gives me a 6x, and together that will give me a 7x. Now I use my principle of zero products. Gives me 0 is equal to x plus 6, and 0 is equal to x plus 1. So we do this by isolating our variables. So I'm going to subtract 6 in my first one, and I'm going to subtract 1 in my second one. And that gives me the answer of x is equal to negative 6, and x is equal to negative 1. But before I box these answers, I must fully check to make sure that both of them work out the way that they should. Okay, so I'm going to check this here. I had 2 answers of x equals negative 6 and x equals negative 1. Let's check them one by one. Let's start with the x equals negative 6. So plug that in my equation. I just substituted negative 6 for every time I see an x. That gives me square root of negative 6 plus 10 minus 4, and we are trying to confirm, does that actually equal negative 6? So on the left, the square root of 10 minus 6 gives me the square root of 4. The square root of 4 simplifies to be 2. And 2 minus 4 actually equals negative 2. So there we see that it does not equal negative 6. So what happened here was when we squared it and solving it, that turned this negative into a positive, which gives us the wrong answer. So we do not include this answer in our solution. That one does not check out. But we still have another answer, so let's see if that one works. So let's check x is equal to negative 1. So starting again by just plugging it into every place that I see an x, negative 1 plus 10, we want to know minus 4, does that equal my x, which is negative 1? So square root of 10 minus 1 gives me square root of 9. Square root of 9 simplifies to 3, and 3 minus 4 does in fact give me negative 1. So the solution of x equals negative 1 does work. So my solution set is the only number of negative 1. Example 3. If you would like, I suggest that you pause the video and try this one on your own. Okay, this one has two radicals, the square root of m minus 1 minus the square root of 3m plus 1. A common mistake that students try and make is they try and actually put these two radicals together. But you cannot actually combine radicals in the form of addition, or especially in this problem subtraction, unless those radicals are exactly the same, which they're not in this problem. You can only add or subtract radicals by like terms. So we have to follow our steps here. Our first step in this problem says to isolate one radical. Now, in the initial steps of these, I told you to pick the more complicated one and isolate it, which means I would try and isolate this 3m plus 1. In this problem, I actually think it's better to try and isolate the other one. And the only reason that I suggest that is because this one has a negative to go with it. Now, if you try to solve it by isolating this 3m plus 1, it'll work out the same. So, what I want to do here is isolate this radical by adding a square root of 3m plus 1 to both sides. That cancels out this radical here, leaving me with the radical of m minus 1 is equal to, now I'm going to write this as square root of 3m plus 1 and then minus 2. And I just put it in that order so my minus is in the middle and not in front. Now I need to power both sides. So to get rid of my square root here on the left, I need to square it, which means I need to square everything on the right. Another common mistake that students have is they think that they can just square each piece. That's not true. Remember, you have to square the whole side of the equation as its entirety. Now, some students try and do that back here as well. Now, some students try and do that at the initial part of the problem. They'll just go through and they'll just square each piece as well. But that's not true because of the same principle here. You have to square the whole side of the equation in its entirety. On the left, you have m minus 1 because your square and your square root cancel out. On the right, since there is an addition or subtraction, meaning here, we have to FOIL this. So, copying down my left. Now FOILing my right. First, anytime I have an exact root multiplied by itself, the roots cancel out, and that gives you what you have on the inside, which is 3m plus 1. Now, outside gives me a negative 2 times the square root of 3m plus 1. The inside gives me a negative 2 times the square root of 3m plus 1. These are like terms. I can add them. Just add the coefficients in front, and that gives you negative 4 times the square root of 3m plus 1. So that's what we put over here. And last, negative 2 times negative 2 gives me positive 4. Now we have FOILed it, but notice that we still have a square root involved, which means that we have to go back to step 1 and 2 and repeat them. So what we need to do is we need to isolate that square root. First thing I'm going to do is I'm going to simplify a little bit. I have a positive 1 here and a positive 4. I can add those together. I cannot include this negative 4 because that is multiplied by that square root. So I have m minus 1 is equal to 3m plus 1 plus 4 gives me 5. And then minus 4 times the square root of 3m plus 1. Now, to try and isolate this root here, I'm going to move my 3m and my 5 to the left. I do that by subtracting 3m from both sides and by subtracting 5 from both sides. Okay, on the left, m minus 3m gives me a negative 2m. On the left, negative 1 minus 5 gives me a negative 6. On the right, I have negative 4 times the square root of 3m plus 1. Now, my square root is not isolated because I have this negative 4 times it here. So technically, I should divide that negative 4 to the other side. But I'm not going to like doing that because if I divide my left-hand side by negative 4, it's going to give me some fractions. And I know most people don't like fractions. So it is actually okay to leave it there. And the reason that that is the case is because it's multiplied. And I'll show you why here in a second. So now what I want to do is I want to square both sides of my equation because that's going to cancel out the square root here. Now, the reason that it was okay to leave that negative 4 there is because it's multiplied, I can distribute my square. So that is like negative 4 squared times my square root of 3m plus 1 squared. Negative 4 squared gives me positive 16, and that is times the whole piece of 3m plus 1, which means that positive 16 has to go all the way through this problem. So 16 times 3m gives me a 48m, and 16 times 1 gives me a 16. Okay, on my left, I have a quantity squared, which means I have to FOIL it. So I have negative 2m minus 6 times a negative 2m minus 6. First, negative 2m times negative 2m gives me a positive 4m squared. Outside, negative 2m times negative 6 gives me a positive 12m. Inside also gives me a positive 12m. So together, that gives me a 24m. And last, negative 6 times negative 6 gives me a positive 36. And I'm just going to carry that down. There. Okay, I am finally down to a regular polynomial. This is a degree 2 or a quadratic, so we can solve it by setting it equal to 0. So I am going to subtract 48m from both sides and subtract a 16 from both sides. So that gives me 4m squared minus 24m plus 20 equal to 0. So we're going to solve this one by factoring. First thing that we notice is we have a common factor of 4 throughout. So let me carry out that 4. Gives me m squared minus 6m plus 5. Of course, that's still equal to 0. Setting up my two sets of parentheses to factor the trinomial gives me m times m, which is m squared, and 5 times 1 to give me 5. To give me a negative 6m in the middle, they both need to be minus. Now, I have something multiplied and set equal to 0, so we set all of our parts equal to 0. We get 4 is equal to 0, m minus 5 is equal to 0, and m minus 1 is equal to 0. Starting with my right-hand equation, solve it by adding 1 to both sides. Gives me m is equal to 1. In my middle equation, I add 5 to both sides. Gives me the answer m is equal to 5. And what do I do with this 4 is equal to 0 here? Well, 4 will never be equal to 0. So whenever you have one number equal to another number, you always just throw it away. Okay, so we have the solutions of m is equal to 1 and 5. Before we box these solutions, we must double check that they actually work in this problem. Because of the length of this video, I am just going to show you that both of those actually do check out. I won't walk you through each and every step. So let's look at these checks here. On the left, we've checked that x equals 1, and we did that by just substituting it for each and every x, and we get down to negative 2, which is what it's supposed to be. So that one checks out. On the right, we check x equals 5 by again substituting it in for every place that we see an x. And we see that it works out to be negative 2, which is what we want it to be. So both of these solutions work. So we can say that our final answer is the solution set of 1 and 5. And that's where I'm going to stop this video.